Also,
Good evening, Atul sir. You can share your PPT.
yeah, good evening.
Yeah, good evening, sir. We have make your co-host.
Okay. Now can I start?
No, sir. Before we will give a brief introduction, then you will start, sir.
Okay.
Sir, you can start sharing your PPT on the screen.
डिजिटली स्मार्ट ना जो है
मी तर ना इसका जल्दी करो काम.
Good evening, sir. All the participants are requested to kindly join in a hurry. We are starting the session. A very good evening to all the distinguished participants, respected dignitaries, and esteemed resource persons. With proud respect and immense pleasure, I, Gaurav Verma, Assistant Professor in the Department of Mechanical Engineering, extend a warm welcome to each one of you. On behalf of United College of Engineering and Research, Prayagraj, to the ACT Atal 6-day online faculty development program, we are gathered here on day 5 of this FDP on the theme Advanced Manufacturing for Industry 4.0, Integrating Additive Technology and Sustainable Practices. This initiative, organized by Department of Mechanical Engineering UCR, stands as a testament to our commitment towards academic excellence, faculty capacity building, and the integration of emerging technologies into teaching and research. Conducting this program under the esteemed banner of the AICT Training and Learning Atal Academy further enhances its significance, as the Atal Academy is dedicated to strengthen the professional competencies of faculty members across the nation through impactful high quality training programs. Now, moving ahead, it's my distinct honor to introduce the first eminent resource person for the day, Mr. Atul Singh sir, Senior Manager Larsen and Turbo Limited ECC Division, Sri Ganganagar. With 70 years of rich professional experience in the field of infrastructure development, his core areas of work includes water treatment plants, sewage treatment plants, and pipeline network projects. He has successfully worked on several prestigious projects across different states of India, including Varanasi sewage system, SAIL steel plant projects, Agra water supply projects, Batla House sewage projects, Delhi, integrated sewer and water projects, etc. He is currently associated with Sri Ganganagar sewage and water supply projects. We are privileged to have with us today to share his valuable industry insights and practical expertise. Good evening very much, Atul sir. We are now welcoming you to start the today's session. There is a technical glitch. Participants, please wait for a while.
Yes, Rakesh.
Yes, sir. The PPT is visible and your voice is also audible, sir. PPT is visible and the voice is also audible, sir. You can
Okay,
start,
okay,
sir.
okay.
Good evening, sir.
Hi, good evening. I am Atul Singh and describes my friend Rakesh and other teams. I am Atul Singh and I am working in L&D from 17 years and I am working in many states of India and basically I am working in my Larsen and Toubro ECC division, that is a engineering construction division. Uh, And in this one another independent IC, that name is uh, WAIT IC, water and influent treatment. That is full form of my IC. Basically, working in this, mainly we are making STPs and WTPs, water laying, pipe laying, and today I am described about this. I hope you can understand and listen carefully. So before I'm starting my PPT, I'm introduce my working culture, my company working culture. Then I understand you are very well understand my PPT. So I'm describing with some photos that working in our company. So I'm also for sorry some internet interrupting connection. So I think Mr. Rakesh,
Yes, sir.
please if disable or any problem, please.
Yes, sir. We'll let you know, sir, if
Yeah,
there's any problem, sir.
that is so. Firstly, I'm introducing my site work because before for working of STP or WTP, uh, we have we have pipeline networks. So is any execution of water laying or pipe laying, what is the difficulties or what is the working procedure? So firstly, we have to do uh, before we are starting at site, our company's policy is a firstly zero harm policy. That means any human, any labor are not even any first aid, zero harm policy. No any harm our labor, our staff. So we are before starting work, we are doing one pep talk session that include what about work doing and what is our today uh, what is our today task and what is the difficulties come in this work. So we are all things are discussed and this is a routine and daily work. So firstly we are given pep talks and starting works. So some of old photos and current photos. So before we are starting uh, our work, we are laying sewer work or water laying. We are fixing alignment. We are fixing alignment for routing of or laying of work. And then in this work we are excavating with JCB. Before starting, I can also tell you about our pep talk that a lot of department are involving this separately. Our quality department, our safety department, and these are also they are introducing some paperworks. So before starting, the paperwork completed very much for us, and that are that's permit of work, excavation permits, laying permits, pipe jointing, that are work are included. So and just you are seeing this, we are excavating, and before excavating, after excavating, we are doing bedding works and then pipe alignment. And yes, you showing these photos. And after laying up pipe, we are punching as per design and drawing. We are doing all these things and testing of water leak test that are after it's called a manhole erection of our work for sewage work. For sewage work, this is a manhole erection work. And after this, these are some currently working photos in cities. So our working area fully barricaded. No, no, because no any interruption, no any other person involving in this working our area. So we are fixing our working area that we are today and working. So we are barricaded, and no working on signboards are also uh, taken treatment, and this is our working process. And this is a called bottling, and it is a electrofusion work. We are showing this because this is a type of work and this is a type of challenges and lot of involving. And this for electrofusion we are using electrical supply. So also an electrical supply in outer field. So also we want other safety parts. That is a part safety we are involving. ये water pipe laying process. We are joining one pipe to another pipe through couplers that are joined by using electrofusion. They're fitting at different type and different sizes. So I'm joining through machine that called electrofusion machines. Uh, this is flow meter. Also, you see the process. That is I'm showing to you that is SDD machine, horizontal directional drilling machine. Called full form is SDD, and this is also for called for underground laying of pipes without excavation. That process is for today's very frequently because without disturbing our roads, our main roads, highways, so easily we can laying this through this machine. We are laid that laying process, pipe laying process, and this is before manhole erection. I am showing you before one photo. One man are standing for with precast. Before this, we are casting this manhole benching. This called manhole benching, and this final product. This process of using vibrator, all these things for quality, because our company is for quality and safety and priority basis. That are lining. Also, some roads are CCs, concrete roads, so breaking with help of JCB breakers. So that is our, and now we are starting WTP and STP. Yeah, Rakesh.
Sir. Yes, sir.
Okay, okay. Actually, सन्नाटा कितना सन्नाटा है भाई तो
Yes, sir.
I am confirming because
Sir, PPT is visible and your voice is also audible, sir. No problem.
thank you, and please confirming me because here some internet problem. Because of
Yes,
this,
sir.
I'm confirming every time. So this is a water treatment plant. Finally, PPTs, our working of water treatment plant, and these are our review. The actual photos of our plant. This is based on our Sri Ganganagar, and I'm describing you for step by step. And firstly, we talk about what is the need water treatment plant. So as you know very well, all of this, water is one of most critical resources for human survival and development. However, there are water available from river, lakes, reservoir, or underground sources in our directly suitable for human consumption due to presence of impurities like suspended soils, dissolved salt, organic matter, and harmful pathogens. And also before sometimes our underground waters and river has very fresh water, but due to our industries and soil pollution, our water is also dirty. So we need before using for treat it, and then you when we use it. Here we are taking raw water from Dung Canal. Here no any river, so in Rajasthan Dung Canal is available, and we are taking raw water from Dung Canal. A water treatment plant designed to treat raw water and make potable following systematic physical, chemical, and biological process. This presentation provides a details overview. WTP, their reference particles, and Sri Ganganagar water supply invested that project. I am working this project. Both of work are here, WTP and wastewater projects, STPs. And before continuing, dear all, one message from me. Please make this session an interactive session so that you all can understand the topic properly. If any doubt, please write your question in chat box. That is very helpful for me for describing you. Okay, and hopefully you can understand. Objectives. What is the objectives of WTB? So, to remove suspended collateral and dissolved impurities, to eliminate photogenic organisms and make water microbiological safe, to improve organelle properties, taste, color, odor clarity, with with other many process. Further, I am explaining you with in detail and with structure, with photo. Just I am describing you that what is problem to ensure that treated water conform to IS 10500 Indian Standard RWHO guidelines. We are follows all treatment and all process as IS 10500. That process are described in this IS codes. To supply water adequate quantity and pressure to consumer reliable. Here what is very important, if any persons are related to living or through Rajasthan, they very well understand what is the water problem, because I am basically from Allahabad, Prayagraj, Uttar Pradesh. So groundwater available for me and we can easily use. But in Rajasthan, groundwater is not available. They are public, are based on our WTPs or government supplies. So these treatment plants are very useful and very important for Rajasthan publics, where they are easily underground water are not available for as a drinking quality. Process flow diagram of a WTP that's shown in our screen. Inlet chamber, screening and grid removal, coagulation, flocculation, sedimentation, filtration, disinfection, clear water reservoir, pumping and distribution. That is small flow chart. I am explaining other activities. Major component of WTPs, inlet chamber, inlet chambers. Purpose, act the first receiving structure to raw water from pumping station. Mainly works of inlet chamber through raw water, very impurities, polythenes and other waste material are receiving through canal. Especially I am talking about our projects because we are receiving our water from canal. So many other impurities are coming through canal, our inlet chamber. That is basic work for so act the first receiving structure to raw water from pumping station, designed to provision to 30% hydraulic overhead and handle fluctuation in raw water flow, facilitating pre-chlorization, injection of chlorine into the raw water pipeline. I am describing you two chemical process in our WTP. First is a colonization. We are clear through chlorine for treating for bacteria, and second is PaCl, polyaluminum chloride, for cementation of water, for accurating for treating for turbidity of water. So these are here described, facilitating for pre-chlorinization, injection of chlorine into the raw water pipeline to control algae and reduce bacteria load. Flow measurement device may be installed. Also, flow meter are installed on our defined, and that measure water amount of water receiving in raw water. For this, we are installing device that called flow meter, and he's connected through all of these are connected through our SCADA system, and we are easily access in one room. I'm sitting in our SCADA room. So as if my background is shown, you are shown. Major component of WTP screening, removals of coarse debris like leaves, plastic, log, and floating matters. Uh, I'm telling you because we are receiving raw water from a canal. So remove of these are very important. Screening that work is screening work. Remove of coarse debris like leaf, plastic, logs, and floating. Some time of big material are receiving from some unwanted material are also received from canal side. For this is very important for us. Screening is doing these all work. Protect downstream unit pumps mixture clarify from the damage and corrosion. Also, purpose of these screening, they are screened, they big materials, so also protect our pumps mixture clarify. That is part of our units, pump mixture clarify. Type of course screen up fine. Then we are using grid chamber, removes heavy inorganic practice, sand, gravel, seed through gravity separation. Prevents wear and tear of pumps and reduce sediment load on clarifiers. I am attaching photos of these structures and these equipments in last of PPTs. Also, I am short describe after showing these photos. So we are I am describing this with photo. What is the work of this related to photo? Major components of WTJ coagulation and flocculation problem addressed. Raw water contain colloidal particles very fine, less than 1 micron, that do not settle easily due to surface charges. This problem was rectified by using PSA chemical. Our name is PSA, polyaluminum chloride, are added to neutralize the charges. Flocculation means flocculation Flocculation, gentle mixing help the neutralize practice to collide and form larger suitable flows. Design consideration. Rapid mixing basin for coagulation, short ignition time, high turbulence, calculator. Sedimentation tank clarifier. Purpose settle flux during coagulation working. Water flows slowly in large tanks, allowing gravity settling in flux. Clarified water moves ahead. If it removes 80 to 90% of suspended solids, these we are pure, we are refined. Our water here through this process, 89% the water are treated through this method. Filtration. Okay, Rakesh, inform me please if any query in our inbox. If any question, please inform. Rakesh,
Any participants have any questions
yeah,
can
please.
type in the chat box and sir will reply to it.
Working of RSF water circulate through a bed and graded and sand supported by gravels. Suspended solid turbidity and pathogenics are removed by physical staining absorption and political actions. Dis disinfection objectives, final barrier to kill are inactive, harmful microorganisms, bacteria, viruses, protozoa. Common method, chlorination, chlorine gases, bleaching powder, or sodium hypochlorite using. Provide residual chlorine 0.22 as you shown, 0.2 to 0.5 mg per liter to protect against recognition pipelines. These are automated system and computerized system. We are fixing amount of chlorine to supply uh, before and after chlorization. So the limited amount of chlorine are mixed in our water. Alternatives are also available. Ozonization, highly effective but costly. UV radiation. UV radiation effective against bacteria and virus, but no residual effect. So UV radiation is very costly and also no residual effect. So we are mainly using in STPs, not in WTPs. Clear water reservoir after treated water, all of this process through calibrator, through our filter bed media passes after chlorination. Then the water are comes in our clear water reservoir. They reserve water for distribution, and this design as based on what is the distribution, what is the amount of distribution in water in cities or distributed network. The size of water reservoir are decided on this basis. These are locating in a WTP, also often underground, and also sometimes is in above ground, but mainly today's located within the WTP and often it is underground. Pumping and distribution system. This is a pumping and distribution system very important for WTPs. Pumping, taking from CWR water and is pumped in directly through pipelines in cities and direct through pipelines. Some areas are directly through pump, or some areas through ESR, that called also also OHSR, overhead tanks, or ESR, elevated service reservoirs, are through directly distribution of pipelines that depend on systems. If area is very flat, so easily we use ESR overhead tanks. One times we are taking water, we are taking water through pumping in ESR, and we and supply in networks in time slotted areas through ESR. So no need pumping in ESR. Only for collecting water in ESR, we are using pump that are placing in WTP, clear water reserve, clear water pump house. No need at ESR any pump. No need any pump in ESR. That are gravity, means water go through gravity. Network of for distribution, we using a network of pipe designed as per demand, pressure, and zoning requirement. Telling you कि, cities are divided in different zones, and we are also divided in district metered areas. So different times we are making a time slot, and we are provided water through distribution system. Ensuring equitable supply with minimum losses. Yes, this project is also designed for NRW because in Rajasthan water is very important. So NRW is very important, and this is a main function of this project. NRW is non-renewable water, and how to calculate NRW? Total supply of water that are measured by we are placed one bulk flow meter in our starting of supply area, that we are making a zone or DMS. So placing one uh, bulk flow meter in starting of pipeline, and we are also installed water meter in every houses. Yeah, through this water meter we are billing through this meter also, and also with reading, help of reading, we are calculating what are our NRW, non-renewable water. The difference between uh, our bulk flow meter reading and total of household water meter reading difference, those difference are occur. This called NRW, non-renewable water. It means the waters are illegal. Anybody taken illegally without metering, or any pipeline leakage. Also, this we are also check if any illegal supplies are not here. So means any pipe leakage, hidden pipe leakage. So water are wasting. Allowable water NRW in our project is 3%. More than 3% not allowed by our government, our client. So if more than NRW is above 3%, so we need more focus in this area. And any we are searching where is any illegal connections, and where is if illegal connections, so rectified and metered immediately. Otherwise, any persons we are theft or tampering any meters. So with help of 2 3 months of how every household meter, we are searching, and we are investigating this reading. We help of this reading, we are calculated, yes, what is where is problem, we are identified and rectified. Because government is strictly for unused water or waste of water. Government are very strict, and non-renewable water is basically NRW is not for name is NRW, non-renewable water, but not for money. Not for money is include renewable water also, because any any house, every house monthly billing is 350 to 450, is not much, is not more, because governments wants to every person save water, no waste, no doing of any water wasting. So because of this we are start meeting, both purpose are solved. uh, Also reading, metering, and collecting uh, money. And our main purpose is we are calculating this help of reading non-renewable water, any waste of water, where is our going to water. Because here as per design 135 LPCD, 135 per person, 135 liter per day design है गवर्नमेंट के थ्रू, by government 135 LPCD project is designed 135 liter per day per person. So we our calculation is based on this 135 liter, and and WTPs and all these things are designed through this. Through this one LPCD 135 LPCD, we are easily calculated to using water in this house, in this some of households are some of streets shops they are using more water. Some of car washing centers, they are using more water. So we can identify through this system. And these are we are receiving these data. Modern system may include SCADA based on monitoring system. We are all our thing, we are sitting in one place, and our RDUs, uh, remote locating units, are in different installed in different area, work with Wi-Fi, internet Wi-Fi. The data are receiving in our MCC building, called MCC building or SCADA room. One person sitting and an operator and seeing this all these things data and receiving very easily in the system. Working of WTP, step by step here. Raw water collection pump to inlet is a summary. Chamber, pre-colonization, screening, remove floating coarse matters. Grit removal, eliminate sand, silt, and heavy particles. Coagulation, flocculation, detail evaluation and aggregation of collidation, sedimentation, removal of local sludge, filtration, disinfection, storage in CWR, pumping, distribution. Uh, this is a case study in my project, Sri Ganganagar project in Rajasthan. Design and part of water supply in wastewater project, inlet chamber with the pre-chlorization arrangement for algae control, hydraulic capacity of design with 30% overloading to meet future demand population. Our system, our system is designed for also for futuristic uh, uh, 2030 and for 2035. Modular design for expansion as population grows. Incorporate multiple units in series, screening, coagulation, filtration, all these things. Ensure water conforms to BIS standard before entering the distribution system. And also, where is working challenges also comes. So some of WC challenges, safety reasons, and other thing reasons. So seasonal variation raw water qualities. I'm previously telling you we are receiving raw water from canal, that names is Gang Canal, and that comes from Punjab. Is Punjab, and in the monsoon seasons, a lot of turbidity are receiving with water receiving with lot of turbidity more than 70-75 microns. We have very difficult to treat this water because our system, every system is limitation. So we are facing in this monsoon season, also in this season, very public complaint are received by us, and that season is also called for us for uh, WTP employees is war time, because every day lot of complaints are receiving from publics about water quality, turbidity, because in this season no turbidity in current time our water turbidity is zero, but in the summer season a lot of treatment process, but we are not achieving less than one turbidity. Turbidity is one or two, so its result some milky's water. The public is complaining for these complaints. Sludge management from clarifier and filters. Uh, Raw water come with soils and sands, and a lot of sludge and sand are produced after filtration of water. This management of these sludge are very, also they are uh, in our reservoirs, collected in reservoirs. Every season before summer, every season we are need to clean these soils and sands. That's called desilting, for more and more storage in our reservoirs. Maintaining adequate chlorine residual without causing taste or the issues. Chlorine maintaining, so taste its traits and other algae and other issues. Energy requirements for pumping and backwashing, skilled manpower for operation and monitoring. Chlorine safety issues are very risky. Any leakage in our leakage in chlorine, they to blunder. So need more and more and more attention in chlorine units, uh, because if you want, then read anywhere what is the risk of chlorine gases. Skilled manpower for operation and monitoring is also very challenging, because uh, these type of men are not easily available. So finding and operating uh, these men are difficult. Describe SCADA. That system is fully computerized and fully dependent or fully on network. This system will reduce our manual works. One man sitting in our SCADA room, they control all of these DMAs, all of these zones, valves, because our in our zones, a lot of step valves and uh, butterfly valves, sluice valves that are operated electrically. So one man are standing in our SCADA room here, clicking one click, and they opening valves from here. Previous after before 10 year 15 year, need man for operating valves, morning times, evening times, night times, but today's we have no any this requirement of this type, because they all are operating from SCADA. SCADA is supervisory control and data acquisitions. I telling you, this control valves and also collect datas. Use and very usually and friendly. And this car, I'm telling you, we are collecting this data. We can easily maintain our NRW systems. SCADA integrated sensors, programmable logical controls, and you know this SCADA operator and SCADA system is very high skill, operated by very high skilled persons. They are not easily available and provide complete function of SCADA and WTBs: monitoring real-time data on flow, so flow, pressure, turbidity, pH, residual chlorine, and tank levels. These are through electronics, through our Wi-Fi with Wi-Fi network. So no any chances of human error here. No maintaining any registers manually, any registers. They are automatically feed in our systems. What is the flow? What is the amount of supplying water? We can easily stability, pH value, chlorine dosing, all these things are fitted in and recorded in SCADA system. Control remote operation of pumps, valves, and chemical dosing systems by SCADA is very easily by and only one person. Only one person can doing all of these things. If SCADA is not available, you need 20 to 30 men for operating this alarm system. So one man can doing this all these things. Alarm and safety. Immediately alert for abnormal conditions such as high turbidity, low chlorine, or pump failure. SCADA is also used for safety for alarming, and as you know, what is the abnormal condition is also showing pump temperatures also. So we are seeing it in this room. What is a if increasing pump temperatures? We know that any wear and tearing problem, any mechanical problem in our pumps, or any heating or ventilation, also in summer ventilation problem. So we can easily solve these problems with help of SCADA, because SCADA informing right time what are all these things are there. Data logging, continuous recording of operational data for compliances, analysis, and audits. That's very, because audits every 3 months, quarterly, uh, half yearly, yearly, by different agencies, by government agencies, by private agencies, by NGOs. Audit are every time, because water is related to our health. So health, for health, so these are agencies are very strict about all these things. Help to reduce energy use, minimize chemical wastage. Also, if you have programming, the doses, fix the doses of chemicals, so they are every time fixed doses are ensured. If these are doing with manual, they are not possible, and also sometimes dangerous for everybody. Advantage of SCADA is WTP, ensure interrupted supply with quality compliance, improve operation reliability through early detection and faults, facilitate predictive maintenance using performance trends, enables remote access and centralized control, reducing manpower needs. Conclusion: SCADA enhance safety, efficiency, and sustainability of modern WTPs, making independent, as you know. Layout: sedimentation tanks, section of rabbit filters. Sedimentation tank, one inlet and one outlet, and during we have fixed sometimes during this time our sludge in go in the bottom side, and after a sedimentation of sludge we are taking water from outlet side. This is a rapid sand filler filter water outlet. Conclusions: a water treatment plant ensuring safe and reliable water supply through a series of treatment processes like screening, sedimentation, filtration, disinfection. Modern automation using SCADA enhances efficiency, real-time monitoring, and sustainability. The Sri Ganganagar WTB examples how advantage technology and effective and designed together ensure safe, continuous, and sustainable water supply for the community, for every person. Some of pictures showing in first, I think you saw my arrow. This is our canal, minor canal. It comes from big canal. Is water control from our sluice gate wall. When we want a large amount of water, then we open the fully our valves, and when we required a small amount of water, they close. We are, it means we are regulate our minor canal through valves. Second is calificator. Calificator is called grid chamber, and also we are describing he's reducing although some big particles in small, and big particles are removing from here. Then after we are including adding PaCl, poly aluminum chloride chemical for sedimentation process, and then comes his filter bed media. His photo is shown filter media bed. His bed made with coarse sand, aggregates, different sizes of aggregate, layer by layers. Water comes through upside and goes through in downside. All impurities, all soils are settled in upper side of sands, coarse sands and aggregates, and clear water through from water side out from our other system. Fourth picture is shown our chlorine room, showing chlorine rooms. Through this, we are in chlorine room very safe. We are very care of these rooms, and very high risk zone, because chlorine gas is. I am describing what is the dangerous and what is the result of chlorine. So this we are regulating through this, uh, and decided to amount of chlorine adding in our water. Post is fifth is a pumping station, pumping is pumping room, clear water pump house. Here design we have four pumps. Every time running three pumps, one for standby. Preventive maintenance we are carried out every time, but sometimes from preventive maintenance. So one 3+1 is provision for any time we are repairing one pump. So other one is running. Here is showing our CWR. Here clear water are storing. Is underground. It's panel room, ST and OST, because we are receiving 11 kV and distribute 440 watt, converting in 440 watt. This also area is also very dangerous, and in for entering this areas, permission are required from our safety department. No any person are allowing without any permit, because here is very dangerous road. Here is in Ganganagar. We are we are made two RWR, raw water reserve called raw water reservoir. Uh, See total 370 ml collected in if tank, both tank are fully, the capacity 372 ml. Firstly, collected water in this uh, in this structure, we are firstly we are collected. We have storage at least 20 days water supply. For water 20 days water supply, we are collected this water 372 ml capacity of. Here shown SCADA room 20 ml. Currently, I am sitting here. The SCADA system are shown in this our system. They are showing this pump running, calibrator running, all the part of watching this through system. Reservoir levels, what is our reservoir level? If anywhere, 10 kilometers, 15 kilometers, no need to go physically in this side. Every time, night time, daytime, every time we analyze these things through SCADA. Water treatment plant, uh, drone view. I am showing you drone view. Water treatment plant. This is a drone view. Our plant, as you know, workshop building, admin building. Here, our SCADA room, our administrating officers are sitting here and operating this clear water pump house. These buildings are filter house, calificators, stress thickeners, and PCL rooms. This project I called IWS and WW project Sri Ganganagar. This called integrated project because they execute waters and sewage system. Both those projects are including water and with sewer called integrated projects.
कपडे कपडे वास काय फिरतो तू कपडे
Anybody? So we closing our WTP processing and we are completing our WTP working. If any question, please put up in chat box. And next we go to sewage treatment plant. Also, Rakesh.
Yes.
Yes, Rakesh. Actually, I am completing this session in 10 to 15 minutes because I have a meeting. So I am completing 7:15. Okay.
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 Please, please continue.
Next is our topic is sewage treatment plant. Because after a lot of you know very well as in our Delhi Yamuna is very dirty because so previous sometimes industrial waste, human waste are directly going to our rivers, canals. So our freshwater river and canal are very dirty, and you all are seeing our Yamuna. What is the Yamuna status? So we need sewage treatment plant. Then government are very sincere and here before in duration of 15 year very projects are coming for treatment of water. So those in this system we are treated water collecting from household and also from industrial. And after treating water they are supplies in term of if we called in Rajasthan. So we are supplying to our farmers for agriculture purpose, and in our UP, Bihar, and other things they are directly supplied to our river or any other cities works for plantation, uh, watering, and other things. Yes, yes. Objectives, the definitions of sewage plant is an facility designed to remove contaminant from domestic, industrial, and commercial wastewater before releasing into the environment diffused. Objective to produce environmentally safe treated wastewater effluent and reduce the population load. Yeah. Prevent water pollution, protect aquatic life, reduce the spread of waterborne diseases, enable reuse of treated water for grading, flushing, or industrial process. Help of it. Main stages of sewage treatment: primarily treatment, removal of large solid and debris. I am showing you what working of, because this system, sewage system, STPs, sewage treatment plant, before sewage treatment plant, we are receiving the raw water from pipelines from household and industries. Before this, we are laid pipelines, constructing manholes in our cities and remote areas. So we leading simply leading a pipe, and these difference between water laying and sewerage laying. Water is pumping are through gravity pressure. Water is supplied through always through pressure, either pumping, either overhead tanks. But sewerage system is totally dependent on gravity system. All water are flow through gravity. We are collecting water through pipeline. Firstly, go to property chambers. Then after called IC inspection chambers, and then automatically with flow with gravity in our manholes through pipelines through networks. It's collected to our STP. Then we start processing of this water, primary treatment, shuttling and suspended solids that collecting from household, some polythenes, balls, and some all types are wastage are collecting in STPs. And STPs operation is very difficult because smelling is very bad. Other problem was treating advanced treatment, further purifying neutralized sludge treatment, processing in other product. I'm explaining with you with this diagram. Firstly, raw seawater receiving, screening bath chamber, raw water collecting, and firstly go through screen chamber. Here we can remove all of solid and all of polythenes and other materials and other balls and plastics, wood. All things are here screened with screen help of screen chamber. Equalization collection tanker. Then if we primary settling tank, we receiving the primary settling tank. All of small particles are settled there. Then we go through aeration tank. They are called also SBR. They are large tank, and here provide we are providing aeration. We are providing air through blower pipes. Big blower are installed in our STPs. They are providing air, and pipes pipelines are here our SBR. So these pipes are air supplies this water, and during area because of SBR they call our aeration tank. Every tank is need 30 minutes for aeration. Aeration means supply of air, bubbling with these airs, and after 30 minutes, secondary shuttle tanks, mainly particles, small particles are settled in our SBR and receiving water, secondary settling tanks. Then we are colonization also here, colonization system for reducing bacteria and uh, uh, other chemicals and other bacteria and germs. Then go to dual media filter, and we receive treated water of reuse. Reuse means not for drinking, it need for treating, but reuse means is all used for farmers and used for industrial purpose, used for planting, plant watering, not for household use. There's some functions of primary treatment are here. Objective to remove large solid. I am also described damage downstream equipments. Major utility concerns. What are doing screening chambers here? Core screening here 25 to 75 mm. Large particles, rag, plastic, paper, roots, all these things. Fine screen carrier spacing 6 to 25. Core screening, then fine screening. Firstly, we filter 25 to 75 particles, then we use 6 to 25. Process sewage process through screening, large solid type and partial clean, maintenance, manual and maintenance raking system. Then it's go to grid chamber. It's grid chamber reduce of flow velocity 0.3 to 0.3 meter per second is very slow, running very slow. So heavier gets settled. The particles to very if velocity due to very slow velocity of this grid chamber, heavy particles are settled down. Lighter organics are matter remove the suspension. Type horizontal flow grid types, many types of grid chambers: horizontal flow grid chamber, aerated grid chamber, and vortex type of grid chamber. Uh, Oil and greasing trap signaling tank. There is also removes debris, flat jet interface biological treatment, sewage held under questioning conditions, lighter soils rise skim surface. Primary treatment second, then you go to primary second treatment to remove certain organic inorganic solid and reduce suspended soil and BOD by physical sedimentation. Primary sedimentation tank working and design are here circular of rectangular tanks. The tank are circulars, mainly circular, not rectangular, mainly are circular. Detention time 1.5 to 2.55. They are taking in one cycle, taking 1.5 hour to 2.5 to 30 hours. Uh, Depth of this depends on design, but mainly 3 to 5 meter are depth of these grid chambers. Sludge collected from bottom via scrapers sent to sludge treatment. Some scrapers are installed in this bottom side. Collecting these are debris so easily through these scrapers. Remove 50 to 70% in this process suspended soil and 40 to biological oxygen demands. Primarily, effluent treatment reduce BOD and SS. Primary stress, thick organic matter state organization. Secondary, biological treatments, microprocess principle. All here are mainly consume organic pollution BOD as flood. Uh, Common biological treatment method, aeration tanks, secondary qualifiers, design parameters. Here is qualifier, biological treatment, uh, modern system are sequencing, uh, advanced treatment, nitrate removal, nitrogen removal, stress treatment. Yes. Mainly, I want to come because I want to explain through these photos so you can easily understand. Otherwise, these are our material are easily available in net. You can easily understand. I'm telling you firstly, we are receiving this raw water, these polluted water in screen chamber. We are removed from all wood debris, polythene, it is here, collecting here because we are laying starting pipe laying from 1.2 meter and laying of I am telling you these all water are through with gravity means no any pressure in sewer lines, so we are reducing levels and finally leading of people after in reaching of STP the level of pipeline minimum 5 to 6 meter depth. We are finally receiving our raw water from household or industry here in 5 to 6 meter depth. Mainly I am completing project in Varanasi. Here depth is 19 meter, approx 20 meter in depth. So collecting in depth of 20 meter. All water or raw water need to treated this water. Pumping required for sucking this water from depth, so we required large water. These are showing pumps. They pump. We help of these pumps. We lifting these waters and send to this. Third picture is showing primary unit collecting uh, this this section. This called primary treating water, and through this grid chamber canal, water comes here. Here is grid chamber, and here is shown aeration tank, also called SBR, sequential batch reactor. Here is shown your qualificators, the depth 3 to 5 meter, dependent on capacity of your STP. Either this STP is 120 mld, 120 mld, but means 120 ml per day capacity of STP, because my Varanasi STP is 120 mld capacity. This capacity is treated water. He is able to treated water 120 ml per day, 120 million liter per day. His capacity, and adding some of other equipments, we can increase this capacity with 230 ml per day, million liter per day. Is designed for 240 and 240, so no need for any other STPs, because he is designed for 2 foot, at least 240 is capable for treating this water. Here is a fifth is showing a picture is a UV systems. So here is last after SBR, we are collecting the water. Here you go through UV that treat bacteria here through UV system. Then he goes to treated water reservoir, and after this water are pumping going through farmers or canals or rivers where the resources are available. These are our activities, and also I am showing one videos that help you to. This is Varanasi. Please see this video. Our Varanasi 120 mld STP plant.
Uh, Atul sir, we have two questions from the participants. Which flow
Yeah, yeah.
meter is used? Which flow meter we use in the water treatment plant, sir?
In the water treatment plant.
Yes, sir.
Yes. Yes. Yeah, this is a picture showing you everybody is Rakesh.
Yes, sir. Sir, one question is in the chat box. Which flow meter we use in the water treatment plant?
Which different
Flow.
companies are hello.
Yes, sir. Yes, sir.
Different companies are producing these flow meters and electromagnetic flow meters mainly using.
Okay, sir.
Yeah.
So one another question is that what role does renewable energy play in water sewage treatment operations? How can created wastewater can be reused safely in agriculture and industrial purpose?
Reuse. Okay. Uh, in that time, we are using reusing in our farmers, our in a river because after treatment we are conducting some test of waters. Without testing, we are not supplying anywhere. The different type of tests, turbidity, colonizations, and other bacteria tests. So this is safe for our farming purpose, uh, plant burning or supply to river or canal.
Okay, thank you, sir, for the answer. Any participant have any doubt, any questions from the sir, you can ask. It's a great opportunity for all of us to ask any question.
Yeah, and also I'm thanking to United College for this given opportunity. And I am here sitting in Sri Gangana. If any person are here uh, around this, if you want to visit our plant, either in Varanasi or here, so I'm easily uh, adjust for visiting these plants. And especially thank to Mr. Rakesh and United College.
Sir,
Thank you.
thank you very much, sir, for your insightful and enriching session. On behalf of the organizer, faculty members, and participants, we express our sincere gratitude to Mr. Atul Singh, sir, Senior Manager Larsen and Turbo Limited, for taking the time to share his knowledge and experience with us. His contribution today has truly enhanced the academic quality of this program. Thank you so much, sir, for giving a precious time for sharing our valuable knowledge and insight with us. Any participant have any question, any doubts, can ask Atul, sir. Okay, sir. Thank you, sir, from our side.
Okay.
Good night, sir.
Thank
Thank
you.
you so much for
Thank you.
accepting
Good
our
night.
invitation, sir.
Thank you. Thank you.
Now, moving ahead, it's my distinct honor to introduce the second eminent resource person for the today's session, uh, Mr. Sanjay Agrawal, sir. Mr. Sanjay, sir, welcome very much. You are now co-host, sir. You can share your PPT also. First, I would like to have a brief introduction of Sanjay, sir. Mr. Sanjay Agrawal, sir, is a highly accomplished professional with 38 years of extensive manufacturing and production engineering. He began his career with Ford tractors, working on the machining of cylindrical blocks, cylindrical heads on HMC and BMC. He then served at Eicher Tractor, contributing significantly to engineering operations, machining, trials, troubleshooting and predictive management, etc. At JCB India, he was the first employee of the transmission indigenous projects where he established the machine shop and developed 2WT, two-wheel drive and four-wheel drive gearboxes, rear axles and four-wheel drive front axle housing. He also received specialized training at the JCB transmission plant, United Kingdom, with which resulted in a 35 production reduction in machining time and 15% improvement in machining shop efficiencies. Later, as project manager at Subros Limited, he held two greenfield projects, including Global Autotech, and successfully established facilities for tube connectors, charge ports, compressor pistons, with technology transfer from South Korea and Japan. At JC AutoFab, he played a key role in the development and standard operating procedure for bucket scissors covering fabrication, machining, CD coating, power coating and assembly. Is the recipient of the Manufacturing Excellence Award at 4th CII National Cluster Summit 2004 and the prestigious Mackie Mechanist Super Shop Floor Award Innovation in 2015. He is widely recognized for his expertise in tooling, fixturing, and gauging, and machine selection. We are truly honored to have such an eminent speaker with us, sir. Sir, it's our privilege to have you with you. You can start your session, sir. We are welcoming you for the starting the session, sir. Sir, please unmute yourself. Sir, there is an audio sign. You can just unmute yourself. There's an icon of audio, sir. You can unmute yourself by clicking it. Participant, you are requested to be patient. There's a technical glitch. Sir will join within a few minutes.
Am I audible?
Yes, sir, Sanjay sir, you're audible, sir.
It is okay now.
You can
Thank
switch
you.
on your camera also, and you can share your PPT, sir.
ओके ओके इरदान मेरी पीपीटी और शेयर करा दे यार ये
हाँ पीपीटी खोल रखी है
नहीं
हाँ तो बस शेयर करो और पीपीटी खोल लो
शेयर पीपीटी कहाँ से खोलूं
मिनिमाइज करो आपस में मिनिमाइज जहाँ पीपीटी है खोल लो
क्या Now my PPT is sharing.
If the PPT is sharing, you can press F5 and the screen is visible on full screen, sir. Yes, sir. It is visible.
It is visible.
And the voice is also audible, sir. Welcome, sir. Welcome.
Thank you, and good evening to respected faculty members.
Good evening, sir.
And I'm sharing today manufacturing process in automotive parts. Auto parts manufacturing process are as follows: plasma cutting, laser cutting, shearing, bending, power press operation, CNC machining, welding, pre-treatment process, powder coating, assembly and packaging. I will also speak about the additive manufacturing later on. This is the plasma cutting machine where we use plasma source for steel sheet cutting. And where we cut the sheet, the edges are not very fine. The improved version of plasma cutting is laser cutting, where we use the laser source for cutting. It is a programmable machine, and the component, whatsoever we want, we have to feed the DXF in the machine programming system, and we cut the every size, every type of part in this machine, and the finish of edges are very, very good. Then we are having third operation is shearing machine operation, where we can cut the straight cutting, angular cutting, strip cutting, trimming excess sheets, cutting large sheets into blanks, edge preparation for bending or welding. This is the operation for shearing machine, how it is working. Here we are cutting the blanks from the sheets. Cut to length size we are maintaining. This side we are collecting the CTL, what we required. The next operation is power press operation. Here we can use mechanical press, pneumatic press, as well as hydraulic press. The operation we can do blanking, punching, bending, deep drawing, embossing, and shearing, straight cutting. Some of the example I will share with you. The top side is the punch and the bottom side is the die. It is a special tool to cut the blank from the sheet. The second operation is punching operation on a press machine. It is a pneumatic press machine. This is next operation is bending machine on mechanical press. Straight blank we are bending on the machine, and this is used in mass production. This is press brake operation. This is the machine which is CNC machine and tooling are standard. We can immediately bend the parts on this machine. When we make prototype or small batches, these machines are required. This is a costly machine. As compared to press machine, the cost is twice or thrice of this machine. And operation cost is also 3, 4 times or 5 times of this machine. But immediately if we want to do bending operation, we can do on this machine. Whereas in press machine, we need punch and die to develop first, design and develop. The lead time is more for that machine. Here we can do immediately bending operation on with the help of brake press machine. And CNC machining. Common operation in CNC machines are cutting, drilling, boring, turning, threading, pocketing, profiling, surface finishing. These are the commonly machined used turning machine and vertical machining center. In turning machine, we have to hold the tool in turret and part will be clamped in spindle. The round part we are making on CNC turning. On vertical machining center, we hold the tool in spindle and part is stationary. It is held on the table with the help of the fixture and tool is rotating. Tool is cutting. This is the example of turning machine. This shows facing and boring operation on a turning machine. This is the example of a vertical machining center, a boring operation. Here tool is rotating. On vertical machining center, we need to have a fixture which hold the component and clamps to clamp the component so that it cannot be disturbed during machining. Now we will reach on joining operations. Joining are two types. One is permanent joining, another is temporary joining. Permanent joining are welding, soldering, and brazing, and temporary joining are mechanical rivets, bolts, and screws. In auto component industries, MIG welding is a process which commonly the maximum used for the joining of the operation, and we use MIG welding. MIG welding process is as follows: clean the metal surface, select wire type and diameter, set voltage, current, and wire feed speed, set shielding gas flow. Gas is commonly used argon oxygen mixture, where argon is 80%, 20% is oxygen. Strike the arc and start welding. Maintain a steady travel speed. Allow weld to cool. Inspect weld quality. I will show you example of tacking and welding. The first process is tacking of a welding. Then we do the welding. This is the tacking of. During tacking, we need a proper fixture and where we have to place the parts and clamp the parts. Clamp will be very easy to clamp the parts so that time should not waste. If you are seeing this red color clamps, it is toggle clamp. Push pull type of clamps. Push is clamping, pull for unclamp. This is the actual time taken for the tacking for this critical part. This is the help of the fixture and the clamps are very flexible. Next is the full welding of the same component. Many parts we can complete in fixture also, but it is a critical part. Approach is not there. Welder cannot weld inside the fixture. That's why we are doing it outside the fixture. Then we move to cleaning process, pre-treatment. When we part manufacturer weld, then it has to go for the powder coating or painting process or a plating process. Before plating or powder coating, we have to clean the part very properly and prepare the surface to adhesion the paint very properly, and it should be corrosion resistance. So it is a 8 tank or 10 tank process. The process is as follows. First is the degreasing. Here we use the solvent as a chemical, alkaline solvent, which remove the grease, dust, or any machining fluid on the parts. Second is the rinsing, where we wash the component on DM water to prepare it has to go next stage and there should not be any contamination. Third is derusting or pickling. We remove rust if any rust is there, or if any carbon layer is on the component, it has to be removed. Here we are using uh, acid, HCl or H2SO4 or phosphoric acid. Fourth is the rinsing operation. Fifth is the phosphating operation. Create a crystalline phosphate layer, increase paint adhesion and corrosion resistance. इसमें टाइप्स हैं आयरन फॉस्फेटिंग, जिंक फॉस्फेटिंग एंड मैग्नीज फॉस्फेटिंग. Passive conditioning neutralize the surface, provides additional corrosion resistance. Then we used to dry the part before painting. It we used to do in a oven. This is the pre-treatment process. This is a fully automatic operation, PLC controlled. How much time we have to dip the parts in different chambers. You have seen here 2 transporters are working in this plant. Next operation is powder coating. Here we load the parts, clean the parts, then we spray the powder. The spray is done by electro-pneumatic guns, and the leftover powder goes to hopper, and the powder coated parts goes to curing oven, and it stays there for 30 to 40 minutes, and the temperature is 220 degree. And there is a cyclone where we recover the leftover powder in the booth, and it has to filtered. Then parts move on the conveyor. It has to cool down, then only we can load. It can be manual or automatic. I am showing a automatic plant of powder coating to you. We are hanging the parts on the conveyor hangers. Then we have to clean the parts. If little bit moisture is there, it has to be removed. Then next operation is air cleaning of the parts. There should not be any dust particle. Parts are entering inside the powder coating booth. The powder spray is a highly skilled job because the depth of the paint is required 80 to 120 micron. These operators are trained how many times they have to spray the powder, how many times they have to spray the powder to maintain the thickness of the paint. It is called DFT. Parts going to curing oven and then coming out, and paint is baked now, and parts should stayed inside the oven 30 to 40 minutes, and the conveyor speed set according to length of the baking oven. The part is moving on conveyor. It is a cooling time for the parts. Specific trolleys are designed and developed to unload the part on specific trolleys. After coating, we move parts to the assembly line. There are different lines for the assembly: engine assembly, transmission assembly, chassis assembly, suspension system assembly, steering mechanism assembly, and there are so many other assemblies also. This is a steering housing assembly. This is the fixture. I have not shown the complete video for that. It was not available with me right now. Then we move these parts to packaging. Common packaging materials are corrugated box, wooden crates, plastic crates, bubble wrap, foam sheets, thermocol, vacuum shield pouches, VCI paper or bag, corrosion protective. For the overseas consignment, we use VCI bags or VCI papers. Pallets, it can be wooden, it can be plastic, it can be corrugated also. This is the corrugated packing. For overseas parts, we pack the component like this, and the pallet is also corrugated. This is one city to another city or the same city. The trolleys are specific to the parts. We are having so many types of trolleys to keep the component for the transportation. And this is a very innovative to design the trolley and develop. And we want to keep use maximum space of the vehicle during transportation. Now I will talk about the additive manufacturing. It is the latest technology, and I have seen once on a VMC machine in BFW Limited additive manufacturing. They are making some specific part on with the help of VMC, and I have seen they are using robot also to making additive manufacturing the parts. It is layer by layer fabrication. It is 3D printer. It is like a 3D printer printing the parts. Layer by layer fabrication of the parts in additive manufacturing. Material used is plastics, metals, and composites. The application is prototypes, aerospace parts, medical implants. Additive manufacturing key fixtures are build parts layer by layer, used metal, plastic, ceramic, and composites. Products which are having complex shapes, and here minimum material wastage is there. Fast prototyping and customization. When we used to make first time any part, we use this technology. This is the latest technology. Very less places it is available. I have not seen in automotive using such technologies. Steps for additive manufacturing is CAD modeling. Create 3D model using CAD software. The majorly using softwares are SolidWorks, Fusion 360. Then slicing. Software slices model into thin layers because it is a layer by layer manufacturing. The program is generated by G code for printing. Printing layer deposition. Printer builds objective layer by layer with heat, light, and binding. Then next process is cooling and solidification of the part. Steps of additive manufacturing. Fifth is post processing. After make the part, we have to remove the supports of the parts. Then sanding or polishing, heat treatment, surface finishing or coating of the parts which we made in additive manufacturing. Additive versus subtractive manufacturing comparison. Basic definition: additive manufacturing, build object layer by layer by editing material. The machine used is 3D printing. Subtractive manufacturing creates object by removing material from a solid block, casting, forging, etc. There may be many more type of raw material. Example: CNC machining, milling machine, turning machine. Process approach in additive: add only the required material. Bottom up fabrication. The component made bottom to up through fabrication. Substantive cuts away excess material. Top down fabrication. It is just opposite the approach is just opposite the additive manufacturing. Material used: additive low wastage, material added only where needed. In subtractive high wastage, chip and scrap generated during cutting. Geometric freedom in additive, excellent for complex shapes, lattice, hollow structures. Subtractive, limited by tool access, different shapes required multi-access machines. Production speed in additive, slower for large parts, faster for prototype and small batches. Subtractive, faster for production for solid parts, suitable for mass manufacturing. Surface finish in additive, rough surface required post processing. In subtractive, smooth, precise surface finish. Accuracy and tolerances in additive, moderate accuracy. Tolerance depend on printer type. Subtractive, very high accuracy and tolerance can maintain in micron level. Material option in additive, these are the limited compared to subtractive, plastic, resins, some metals and composites can be used. In subtractive, wide material variety, metal, plastic, wood, foam, composites, ceramics. Cost consideration in additive, lower cost for prototype, high cost for large parts, time and material is costly. In subtractive, high cost due to material removal, efficient for large scale production, efficient for mass production. Application in additive, we make prototyping. Custom complex parts, medical implants, lightweight aerospace component, additive manufacturing is suitable. Subtractive, automotive parts, machine components, precision tooling, mass production parts. Subtractive is very suitable. Thank you. My presentation is over. Now we can discuss.
Any participants have any questions regarding these PPT shown by the sir? Sir, we have some questions in the chat box.
Okay.
They have asked, what are the challenges in manufacturing from China? How can we overcome them?
Actually, we are making only assembling machines. The precise part we are not making in India. Yes, it is started right away, but it is very slow. China is making everything. Taiwan is making everything. We are making CNC machine, but all the precise part we are getting from Taiwan, China, Japan. And the CNC system we are not making. Even Taiwan is making their CNC system. So we need to really work hard. We are making parts for the India only or export little bit. China is making parts all over the world, not for China. This is the difference between them and us. And our approach is not like them. In our place, chalega. They do precise. Before, we are getting precise machines from Japan, Germany. Now, the similar machines we are getting from China. But India is far behind. We have to really work hard to develop these things. And the institutions and the big manufacturing companies has to spend on research and development so that we can stand ourselves like China, America, or Germany, or Japan.
Okay, thank you, sir. The next question is in the chat box, sir. Give some example of additive manufacturing in auto industry, sir.
Sir, auto industry, it is not there, but the tooling we are using on CNC machines, some of the companies started making those tools on additive manufacturing because it is giving more life and more accuracy for the parts. But right away, I have not seen in automotive industries this is using. Or I can say I am working at this time for part supplier to the OEMs. So it may be OEM is using, but part suppliers are not using this technology right now.
Sir, what is the difference between the permanent joint, semi-permanent, and temporary joint in
Actually,
the industry?
permanent joint is a welding, is a brazing. These are the permanent joint. And when we tighten the part with the nut and bolts, it is a temporary joint. It can be opened whenever it is required. So some places,
Some example of semi-permanent joint in industry, sir.
sir, in industry, if you have seen the JCB, so many parts are permanent welded. If you see the outer, all the parts, bucket, shovel, all the parts are welded. If in case of transmission, engine, gearbox, rear axle, these are the temporarily joining. Everything is joining temporarily. Whenever we want to repair, we can open it and we can repair it.
Okay, sir. Thank you, sir. Any questions from the participant side? You are most welcome. We have a great opportunity
Sir,
having Sanjay sir with us.
one question from my side.
Yes.
Sir, what is the basic limitation of laser beam machining during the operation?
Laser beam.
Yes, sir.
Laser beam is a no limitation. Whatsoever shape you want to cut, you can cut the part from the sheet. And the limitation is the high thickness. We cannot cut more than 30 mm or 35 mm on laser machine. This is the limitation of a laser machine.
Okay, sir. One more, sir, question. What is the basic difference between the electron beam machining and laser beam machining?
No, I don't know.
Okay, okay. Thank you.
Thank you.
Good evening, sir.
Good evening.
Sir, how we decide that what amount of powder coating is going to be applied in respect to the any component or?
Actually, it depends how much DFT is required. Most of the cases, the DFT required is 80 to 120 micron. So initially, we do the trial on the parts by doing spray of powder, and after baking, we used to check how much it is coming. So we trained the operator how much he has to spray, how many time he has to do the up and down the process. So this is a purely experience based method. So we set like this only.
Any other questions?
From my side, there is a question. Using unconventional manufacturing processes or machining process, it will be highly expensive. Can we optimize it to make it some less expensive?
Actually, it is not very expensive when you use the machine in a proper way. And the machining is decided based on the component requirement. If it is a part we are manufacturing for engine, it is a very precise part. If we are making part for transmission like gearbox or rear axle, these are the very precise parts. But nowadays, next generation tooling is available where we can use machines are very good available. If we use the machine proper parameter and minimum cycle time and maximum quality if we can achieve, then it is come in the right cost. And there are processes available, tooling available for those we can achieve these things.
Sir, there is another question. What is soft tooling in additive manufacturing?
Actually, I have seen only once, so I cannot tell much. It is working like 3D. The material is layered by layered. It is like a welding. It is 70 micron layer every time. So on the layer to another layer, it is fabricated. So I cannot speak much about this. I have studied and I have seen 2-3 places, so I am able to tell you something, but not very much. I don't know very much.
One more question, sir, from my side.
Yes, sir.
I am Dr. Mohan Gupta.
जी,
सर
welcome, sir.
सर थैंक यू सर. सर मेरा कोई सवाल नहीं है, We just want to know about the brief about your company, about the industry in which you have worked. So please explain in 5 to 10 minutes, please.
सर एक्चुअली मैं अभी पंचाल मैन्युफैक्चरिंग कंपनी प्राइवेट लिमिटेड में काम करता हूँ
जी जी
और हम मेजरली सप्लायर हैं जेसीबी के लिए और सीएनएस ट्रैक्टर के लिए ऑल्दो वी आर हैविंग अराउंड 20 customers for us and we are exporting parts to Canada also and we are starting exporting parts to US also. जितने भी मैंने आपको वीडियो दिखाई ये मेरी ही कंपनी के हैं
जी जी
सिंस बिगिनिंग टू एंड वी डू एवरी ऑपरेशन इन हाउस जैसे मैंने आपको दिखाया कि हम शेयरिंग करते हैं हम मार्केट से शीट्स को परचेज करते हैं इन बल्क अकॉर्डिंग टू थिकनेस एंड लेंथ वी कट CTL and each process we do in house very precisely. I used to tell we are a technology company. We are having CNC machines in house. We are having plasma cutting. We are having laser cutting. We are having brake press. We are having press. We are having design center. We are having tool room. And we are having a team for dedicated for customer parts, new parts development. At a time, 50 parts we are developing with the help of our team. Nowadays, customer is changing their present model to future model very fast. Any car you see, any JCB model, they change every 2-3 months and they are coming with the varieties in the market. So we established ourselves because we are a 40-year-old company. So earlier it was very slow. What is going on? It is going on a regular basis. Now the change is permanent. Everything is going to change. Change is happen. So we are working in the same way for the customer. In JCB is having so many countries their plant, Brazil, USA, UK. In each plant, we are supplying parts from Panchal Manufacturing Company Private Limited. This is the brief introduction of our company. We are having 3 plants. One plant we are making clamps, small automatic machines are there, CNC machines are there. In my plant, we are having press machines, brake press, welding shop, and PDI, chipping shop, CNC turning, vertical machining center. Then we fabricated parts we ship to our powder coating plant and assembly plants, where we make the finished goods and pack and transfer to customer. This is the brief introduction of my company.
Sir, one last question from my side.
Yes,
Sir,
sir.
as per your opinion, which field is good for the student career, production, maintenance, or quality? As per your suggestion, in which field a student can grow themselves?
Sir, my suggestion is any field is the best. The person goes in any work, he has to take interest because the mechanical field demand very hard work. So who is ready to do hard work? Actually, every corner, every place there is an innovation. Any company is a big university. You will find the different operations are going on. If a person is loyal to his work, he will achieve anything. And my country need such young generation who has to take interest in their work. So any field in mechanical, whether it is maintenance, whether it is purchase, whether it is production planning, whether it is designing, whether it is quality control, every field is very interesting. I worked all the fields. Development also, I did so many developments, thousands of development I did, and I am hands-on. My advice to students, they have to work minimum 5 to 10 years directly on machines. Directly, they have to know, otherwise they will not having any feel, they will not enjoy their work. This is a very creative work. You enjoy like anything. I have enjoyed last 38 years And till today, every day, I enjoy my working.
Thank you, sir, for your wonderful answer. Thank you very much.
Thank you, sir.
Sir, one more question, sir, from my side.
Hmm.
Sir, how many percentage energy saving in additive manufacturing as compared to conventional manufacturing?
Sir, I can't reply because this comparison I am not having. But I can say in any industry, we can save energy 20 to 30% by using only common sense, by using only cleaning of the electrical parts, by using checking their heating and what current they are drawing the motors. The motor is appropriate, how many HP motor is required. By doing simple things, we can save the electricity. Another example is air. Air is having so many places leakages. If leakages are there, compressor has to work more. And the compressor is work more, then electricity bill will be high. And there is a big amount of compressed air cost in a manufacturing industry. So we have to work very carefully. And there are check sheets. We need to fill it very properly. We have to keep our machine clean. We have to keep our wiring clean, dressed up. So we will save the energy. This is the mantra.
Okay, sir. Thank you.
Thank you.
Sir, some other questions are there in the chat box.
Hmm.
What is the difference between powder coating and liquid painting, sir?
Sir, the powder coating is a powder, and we have to spray powder in the part, and it has to be cured at 220 degrees centigrade for 30 minutes. In liquid paint, we have to spray the paint directly on the surface, on the component, and it has to be cooled down and solidified. This is the difference between powder coating and liquid paint. And the powder coating life is very high. If you have seen in the video, after powder coating, he placing the parts in trolley in a very rough way, but the part is not damaging, paint is not damaging. In case of liquid paint, it damage very fast, and the life of the part is very high in the case of powder coating.
Thank you, sir, for the answer. Next question from Dr. Naveen is, what are the recommended curing temperature and time for powder coating?
The 220 degrees centigrade, 30
220
minutes.
degrees. Okay, sir.
And we used to, in automatic plant, oven length decided, part should stay there in 30 minutes. So conveyor speed decided on the basis of the length of oven.
Thank you, sir. Any questions from the participant side? Sir, there is one question. What is the effect of strength on material after powder coating? What is the effect on strength on material after powder coating? In the
There is
chat
no
box.
difference. There is no difference for the strength of the part, but it is baked very properly. In case of powder coating, the life is very good. 220 degrees centigrade, there is no difference in the steel. There will not be any difference.
Sir, one question from the participant side. How can academic institution interact or work jointly with you and your company?
Sir, most welcome. If any training required to the students, we are always welcoming. And if you need our expert people come to your place, Most welcome. We are ready to give our services also.
Students are eligible to do training in your plant.
Sir, one question is there. What is the status of Industry 4.0 application in your company?
Sir, actually, I have worked in a company where Industry 4.0 was implemented. It is a very good system where we connected all the machines with the software and where every minute, every real time monitoring used to be there. And that system generates what is the efficiency of the machine, where we wasted the time, and it can calculate automatically कि machine is running 70%, 40%, and there are so many modules, maintenance module, quality module, instruments are attached with the software. The operator check the part and the reading of the instrument goes to the software, and it calculate the process capability of the machine. And the in maintenance module, the sensors are placed on a various places in the machine, and those senses and tell predictive maintenance कि this temperature is going up, you need to check the motor. So this is a very good system where we implement Industry 4.0. 10 to 15% the productivity will improve, and minimum 2 3% quality rejected part will come in okay parts. This is a very good approach, and I used this approach, and this is a good approach, and every company has to adopt this approach. Most of the companies, those are having very precise machines like CNC machines, machining, they implement this Industry 4.0. Next month we are going to do the trial on a press machine in our company with a Pune company. They do trial on our press machine. This is a good system, very good system, and many Indian companies are working for that system.
Sir, there is a question. What is the microstructure behavior between additive and conventional manufacturing?
Actually, the strength of additive manufacturing is more because it is a layered by layered fabrication, and there is no force cutting. In other manufacturing processes, when we do the welding, there is a distortion. There is a high temperature material used to melt near the welding. So it affects the structure, and there are stress developed in the welded parts, and many precise parts where the life is required in the field and they do destructive operation, we used to do stress relieving for those parts. In even machining also, there is a huge amount of force is required for cutting the parts. So additive manufacturing is much better as compared to the conventional processes.
Thank you very much, sir. Any other question? Thank you very much, sir, for your insightful and enriching session. On
Thank
behalf
you.
of Department of Mechanical Engineering, UCR, Prayagraj, and the AICT Atal Fdp Organizing Committee, I expand our heartfelt gratitude to Mr. Sanjay Agarwal, sir, for sharing his valuable knowledge and vast industry experience with us. Your session has significantly enhanced our understanding and added a great value to this program. We are sincerely grateful for your time and contribution. Thank you once again, sir. Sir, you have answered a lot questions of our participants with patience. So there is one other question. if you apply 5.0 in your industry, then what are the main factors in consideration?
Actually, my main factor consideration are only two. One is the productivity has to go up, and we have to remove rejection rework from our system. These are the two main objective. And also, third objective is to reduce the breakdown, and it has to come breakdown to preventive maintenance. This is the three objective we have to fulfill from the industry 4.0, and we are on the path of it. First trial we are going to do in December month. Actually,
Thank you,
in
sir.
December, most of the OEMs are having a maintenance closure in their plants. So we don't have any work. So that time we do this improvement activity in our plant.
So the participants have shown some comments in the chat box. They have given a lot of thank you to you and for your
Thank you.
interactive session, because we today we able to know the real life applications of these technology with the help of videos. You have shown us the practical knowledge of it, sir, because we only know the theoretical, because this is the first time we have seen the practical working of all the products within the industry with the real videos of the industry, sir. This is a very fruitful and interactive session, sir. We are looking such great session in the future also, sir, from you, sir.
Thank you.
Thank you for
Thank
your
you very
time,
much.
sir. Thank you for your patience answer, sir. And thank you for
Thank you.
accepting our invitation, sir.
Thank you.
We
Thank you for
from
everything.
United Group of Institution and from ASAT, wholeheartedly thanking you, sir.
Okay, sir.
Good night, sir.
Okay. Good night. Good night.
For the participants, we have a feedback link in the chat box. You can click on it and fill your feedback link quickly. For both the session, we have the link. If anyone of faces any problem, you can contact us. Okay, thank you everyone. Now we are concluding
Sir, where is the feedback form given?
in the chat box link, sir. There is an important information for all the participants.
Share the feedback link in the WhatsApp group if possible.
There's an important
Sir, if possible, share the feedback link in the chat or WhatsApp group.
yes, sir, we are sharing it, sir. We are sharing it. There is a important message from all of you. Tomorrow the session will be start from 2 p.m. There will be a three session. First session is from 2 p.m. to 3:30. The second session is from 3:30 to 5 o'clock, and the last session is from 5 o'clock to 6:30. After that, the validity session of the FDP will be conducted. After half an hour session, you are required to fill the question answer round and all the formalities regarding the getting the certificates. So now we will meet tomorrow at 2 p.m. So you are requested to kindly update the time. It is not 6 p.m. tomorrow. It is 2 p.m. We have three sessions tomorrow from the industry person and from the academics person. And we will also sharing the feedback link in the WhatsApp group also. Don't worry for it. Thank you so much, all the participants, for the wonderful questions you have asked from the resource person. And thank you, the resource person also, for their answers. So good night from our side. We are closing the day 5 session today. Thank you everyone. Good night, all of you, all the respected participants.